So I'm going to start it. So first of all, happy Halloween, Brandon. Welcome
Thanks.
to a special edition of Goth Data Products. If in case anyone's wondering why we're both red, um, if they're watching, those on the listening to the audio only don't get the benefit of seeing us in this kind of like spooky color scheme. But welcome.
Yeah, so thanks for having me on the podcast. I'm excited to talk about, Protomaps Data Source Cooperative. I'm here to answer
Yeah,
questions, I
no,
guess. Yeah.
likewise. And sorry, I did chicken out, so I've changed the lighting, so I'm not red anymore. Yeah, no, it's great to have you. I mean, when we started this thing, you were sort of really top of mind of somebody who's been very thoughtful about about what I would call what we call the ergonomics of data, like figuring out how
Right.
to make a lot of data accessible for people. Um, so if you don't mind, let's just start there. Like, can you just how do you describe yourself and what you do?
Um, so the way I describe myself is I started a project called Protomaps 6 or 7 years ago, and the impetus for this was making it easy to make a map. Um, and the direction that came from was very much just like if you think about a web developer that is making a website, like, so for example, they're making like a site to look up different cafes in their neighborhood. Um, they might use something like Google Maps, but that is like a proprietary SaaS that they buy. And
Right,
like, so I really wanted a way to sort of have like a home cooked way to make a map, because there's so many things you can publish on the web. You're able to publish videos, you're able to publish pictures, or Markdown or HTML. But being
right,
able to publish a interactive map has never been that way. So really, the way I approach this is from the idea of like making it accessible for anyone to publish a map.
got it. Okay, and so amazing, and you've done it, and so you've reminded me. So one thing that we're going to be doing. I mean, I'm just going to like say these things out loud, which is kind of funny. Is like part of the reason for doing this podcast is like we're doing so much stuff at Radiant Earth, and we need like more channels to be able to talk about it. And so just last week, we put out a white paper, and this will be in the show notes, and I'll put it in the chats. But it's called Emergent Standards. And so what you said is just like very relevant to this, which is that like in the paper, I argue that the web has turned out to be a really like an engine that helps people come up with new data standards. And so if you look at it from through that lens, you have HTML, which is like let's share a document, and hypertext, like hyperlinked documents with one another. And then you're like, well, what if I don't want to load up a web page, but I want a feed of updates? And so RSS emerged out of that. Um, GTFS emerged out of the need for like standardized transit information. And I would say what you're doing, and I guess specifically with PM tiles, is like a way to do this for vector tiles.
Yeah, I have a lot of, I guess, thoughts about the idea of standards in general, both in the web and also for geo. I think a lot of the web we think about them as standards, like for example, HTML like evolved very early,
Yeah.
and like maybe on the early web there was a lot of more sort of like it was in the design phase where people would collaborate on creating some spec, and that became a standard. Nowadays, what you see is it's more like if one of the big companies that makes browsers like Google or Microsoft, they sort of like make everyone adopt a standard because it's in their incentive to do so. Like if Google can convince everyone to use what is it like JPEG 2000 instead of plain JPEG, then they can reduce
Yeah.
the amount of bandwidth on the internet by like 20%. And and that is sort of like um, all that tech around things like serving video, serving audio and images is all like very mature to where
Yeah.
you don't really see a lot of emerging like standards being adopted organically. They're more like there's this committee at these like huge companies that like all
Right.
collaborate on a standard. There is some examples of other of sort of more like small scale solutions that became adopted, and that's really how I
Yeah.
see PMTiles fitting in with them. Is like I don't want it to be top down. Like I don't want people to like make their organizations adopt PMTiles. I want people to use it because it solves a
Right.
problem for them. Um, there is a really cool format for images that I like. It's called QOI. I think
Oh,
like it stands for literally like the quite okay image format. Like it's very modest in its like it like in its name, but I
okay.
think it is just like one guy came up with a way to do lossless compression of images that is a lot simpler than PNG and is like good enough. It's not like more optimized, but it's like way faster to decode like on a CPU thread.
Yeah.
And that is like one good example of a not like a standard from like a standards body, but of something that like had a simple design that became popular. Um, and it was
How
not
popular? I've
adopted
never heard of it.
because it's like I think it's used. The original motivation was like for games, like if you have game assets and you need to be able to like decompress them and move them around in just like raw RGB formats. Then QOI is supported by like some of those engines. Um, but actually, like another one you mentioned is GTFS.
Yeah.
So GTFS is like more geo adjacent, and that was it. Also came out of I think Google's requirement to like have some systematic way of storing transit routes.
That's right.
Um, but it wasn't like some sort of consortium of transit agencies that came together to design like this like CSV format. It was like it just became a widely adopted solution because it happened to be good enough. Um,
Right. Yeah.
and that's really
Well,
how I see PM tiles. Yeah.
yeah. Well, so yeah, I mean, it happened to be good enough. Also, Google had this cruise ship that everybody wanted to get on. Is I think I don't know who first said that, described it that way, but like every transit agency in the world was like, we want our data to be in Google Maps, and so they had an incentive to do that. And so that's a concept we explore in the white paper, which is like you do need this mix of like good enoughness because that is usually where things land. Is you have something that's good enough for a lot of people to adopt. They're like, this is fine. I mean, sorry, what's the acronym for the image? Like adequate. What is
Uh,
it?
quite
Adequate
okay.
qual. Quite okay. Like I love it.
Yeah.
Like that's usually where things land. Like RSS, the story of RSS is like a bunch of people fighting and a bunch of attempts at like top down approaches to syndication until people kind of threw their hands up. And but tellingly, then the New York Times adopted it and started publishing RSS feeds, and everyone's like, okay, this is what we're doing now. So anyway, it's fascinating to see. How do you have any sense for the traction of PM tiles as being like this? Like who's using it?
So I have a couple of like proxy ways. So I don't actually know how many people are using it because because by nature I can't like track. I can't add like a tracking pixel each time someone looks at a map.
Yeah,
The one thing I can track is the number of npm downloads. So npm is like the package manager for JavaScript, um,
yeah,
and that is the most popular. I think the most popular client for reading PM tiles, and it's something that I maintain, and that crossed like 100,000 downloads per month, or it's either per month or per week. I can't remember. Like this year, so you can see like a growth curve of people using this library. Now, I don't actually
yeah,
know if that means anything because it could just be like an automated CI script, like on GitHub Actions, that is downloading it like 1,000 times. But it
yeah,
has some correlation with usage. So the only way that I can kind of see if people are using PM tiles or if it's being adopted is through this like proxy metric, like npm downloads, or
yeah.
people show me like a site that is built using it. So actually, like probably the biggest one is like I think the New York Times had a visualization on their homepage that was about like a space debris falling to Earth,
Okay,
and that used it used a map data set that was served from PM Tiles. So probably like
okay.
a data set that's being served on the New York Times like front page in PM Tiles format is like probably like the most high traffic use of it. Um,
Here we are again with the New York Times. It really, I mean, it's kind of interesting. I mean, if you think about the legacy of the New York Times as being like the story about them sort of crowning RSS the standard for syndication, like that's true. Like they did that, and like they do have the imprimatur to do that kind of thing, which is that's awesome. That's great. Like that is a sign that you've made it. Shout out to Tim Wallace, who probably had something to do with
Right.
the New York Times using PM tiles. Um, that's awesome. Okay. Well, so one thing I can say though is like on source, we host a lot of PM tiles files, and you can correct me on all of this. Like there are some kind of like base map objects I think that are in there or something like that. But there, if I search GitHub, is one of my favorite things to do is to search GitHub for references to the source data proxy, which is data.source.coop. And as of today, earlier today, it's like 612 results pop up when I search for it, but a lot of them are to PM tiles files. Do you know anything about? Do you have any insight into that?
Um,
or
right.
or aware of that? Yeah.
So the project I run is sort of an umbrella project called Protomaps, and
Yes.
PMTiles is
Yeah.
just one part. And that
Okay.
was by design because I never thought it would be good enough to just design a format. Because it's like if you design a format, then you also have to have like some killer app that makes people actually care. Because just
Right.
having like a spec with some implementations is like people are like, that's cool, but like I can't immediately take advantage of it.
Right.
So the way I approached it was to have like a killer app, which is a base map or like what people think of when they think of a map, which is like you look at it and there's like city names and there's like water and like roads and stuff. That's based on OSM. So the
Yeah.
actual data product that is like open source and free by default in the PM tiles format is this base map that's from OSM. And I think a lot of the links to source are to that
Yeah.
because going
That's what
back
I
to
was
what I started
guessing.
with, it's like if people just want some solution for showing a map on their site, like as an open source replacement to Google that they can run themselves, that they can copy and they can move around, they can download like so as if it was a video or an image. um, but I imagine a lot of the links are to that just because it's designed to be something that's like immediately useful. Now
Yeah.
I think with source, I think the cores policy is like quite open. So if there's other data sets, like a scientific data set that is in PM tiles format, people could
Yeah.
link to that. And hopefully people do that more, or they download from source and mirror to their own buckets and use that.
Yeah. 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 So I mean, this is something that we're going to have to do our own analysis on this at some point. Um, which is like, what is the cost of us hosting those objects? Because yeah, our core's policy is wide open, so people can do that. Um, and we can do the math on this. But I mean, shout out to AWS. Thank you to the AWS Open Data Program that still exists after
Yeah.
yesterday. Not anyway. It was a tough day for a lot of people at Amazon yesterday. There were a lot of layoffs, but the Open Data Program is alive and kicking, and so they subsidize all of our storage and bandwidth for Source. But we do want to get serious about this at some point and have an understanding of like how much should it really cost to do something like this at what scale. We we have all the analytics we need. We just haven't sifted through the data yet to figure out like which of those objects are being hit the most and how much and what's the throughput that's going out. Because I know you've done analysis on the cost of doing these things. I imagine you have some data on how much it costs to deploy PM tiles, but we also have a lot of this data, but we just haven't shared it yet. So
Right. So going back to that for a moment though, so I
sure.
wonder if you think about like that idea of like being able to search for GitHub for all the links to source for people that are like
Yeah.
hot linking to it. Like
Yeah.
in some sense, like I think it's not directly correlated to success, just the number of people that are consuming source. If
Of
people
course
are
not.
making a
Yeah.
copy of the data, if people are copying the data they get from source to their own bucket and then using that is still
Yes.
like using the platform as intended. Like there isn't really like by design, I don't know if source is designed to be like an intermediary platform. Like for example, like Airbnb. So for
Yeah.
Airbnb is like you go to the site and you look up like bookings, like listings. but they will
Yeah.
stop you from trying to go off the platform to like make an arrangement with like your host, because that's exactly against their business model, right? That's like so it's
Yeah.
for Airbnb, the entire point is like they're an intermediary between you, like your desire for a room, and the host. Now, so
Right.
I don't think
Right.
Source is by design as like a data platform to be an intermediary for all data. There is a lot of like open data platforms in the past that have worked that way, where they make it very difficult for you to be able to consume the data outside of their platform. But it feels like with this sort of cloud native focus, part of the idea is that you're able to, just like package up data and take it to go, or access it just in chunks instead of having to be locked in to just using Source.
Yeah.
So if there was some way to maybe promote that as like a first class way to consume Source instead of just linking to assets, then maybe that
Yeah.
would help alleviate some of these ideas around like cost sharing for bandwidth.
Yeah. Well, no, I mean, let me address this, and then I want to acknowledge we have a viewer, Sig Till, who I'm not exactly sure who they are, but they're Sig Till on YouTube, who is joining us from Norway. So we're like, let's do this at 4 p.m. Pacific. Sorry everybody in Europe, but we're doing it Asia Pacific, or at least, I mean, it's 7 a.m. where you are, so like we're kind of in a weird time zone right now. But we had somebody from Norway tuning in to ask what's in the future for PMTiles, and which changes would you like to see in the format itself, or new tools that use the format. But anyway, Sigtil, just don't go to sleep just yet. We'll answer your question. The vision of Source is not so much to be an intermediary. Source is by design, it doesn't really do much other than provide reliable access to objects. So we call it's a data publishing utility. It's not an analytic tool. I'm happy to I want people to build stuff on top of Source. So that, yes, I do want people to link to it. However, this is math this is kind of my point in saying we have to do this analysis on our usage is to say, like, well, how much is that really going to cost us if we do that? And are there ways for us to get a handle on bandwidth and usage so that we're not abused, or rather, abuse isn't the right term, but just so that we can afford to do that in a way that's reasonable. And to say, like, look, if you don't want to host your own object somewhere, which tons of people don't, I mean, sort of a core tenet of the product design is that, like, we just know that a lot of people don't want to host their own stuff. Like, they don't want to run their own servers. They don't want to think about infrastructure at all. If we can let them just link to reliable assets that are available, that's great. But we have to figure out a way to do that in a way that doesn't, could scale to the usage of something like Google Maps without bankrupting us. Then that means we have to figure out, for example, with like the open cores policies, do we have to have some sort of way to say, like, oh, no, you have to be put onto an allow list to be able to link to this or something like that. We're going to have to figure that out. So you're right that I don't want to be an intermediary. We're not really trying to lock people into Source, but we do want to provide a service that allows people to access data without having to download and reserve their own copies if they don't want to do that.
Right. I mean, on the other hand, I feel like so part of the messaging is that just having object storage is a commodity. And in my experience, talking to developers that use PMTiles or that use other cloud data formats, a lot of people find like using S3 very accessible. And it's not a huge lift to ask them to be like, hey, go put this thing in your bucket.
Yeah.
It's even among like non like so I would say you could just be a front end developer. You could be someone that spends all their time doing TypeScript programming and know nothing about like servers, and you can figure out
Yeah.
like object storage. So I think part of the selling point I'm
That's
trying
my
to make
story.
is like exactly,
Yeah.
yeah. Like that audience I think is extremely large of people that like it's too much of a lift to host something like a server, but
Yeah.
just putting a thing in a bucket is actually like a very good experience. Is like it's very simple. It has a nice abstraction,
Yeah.
and if you can sort of encourage the world to be more object storagey, that's the way I think about it, and that's a big part of why I think PM Tiles as a format has succeeded. is because that audience is so large.
Yeah, totally. I mean, so yes, agree. I'll just tell a bit of history. I mean, I've told the story, tell the story a million times. I'll probably tell it a lot as we keep doing this podcast. But like the story of the origin of the cloud optimized GeoTIFF and all this was when I found myself at AWS building this open data program, and I figured out this one weird trick that I could just get the company to give out free S3. But I had no engineers. I had like that. I was embedded within a sales organization. So like due to like HR practices, like the idea of hiring engineers to build software or tools or anything was out of the question. And so I'm like, what can we get away with if we can only use S3? And I also being kind of, I guess I would say a front end guy, although I've never been like ever officially hired as an engineer. Um, Loved S3. It's like very intuitive product, super powerful, very capable. I wasn't afraid of it. Um, and so I'll say this, like you, very talented, smart person, knows how to use S3, isn't afraid of it, and neither are your friends. There's tons of people out there that are afraid of S3. Like Source, and actually, I got to shout this out. We've been working with Development Seed on Source. Anthony Lukash, shout out to Anthony at Development Seed, has been just cranking out new features on Source. Today, we pushed out like you can upload stuff into S3 through the browser through Source. So for Source users now, which you still have to be invited to be a Source user, you don't even have to use the CLI. You don't have to, don't have to look at the AWS console. Like I'm just here to tell you, there's a whole universe of people out there that they're like, no, I am scared of S3. Like I'm scared of AWS. Like I don't want to look at that console. And I saw somewhere some tweet that was like, it was in reference to Vercel or something like that, but it was just sort of like, it's amazing how big of a business you can build just by building an abstraction layer on top of the AWS console. And so that's really what we're trying to do. And in fact, I mean, like I do hope there will be people in the future. I mean, we already have a bunch of other organizations that are hosting their own PMTiles on Source. They would rather put it on Source than host their own S3 server. So, or rather, like manage their own AWS account. So I'll leave it at that. Let me make sure. I'm hoping Sig is still awake in Norway. Do you want to take this question? What's in the future for PMTiles?
What's in the future? I would say the current version of the spec, version 3, is done. There aren't any plans for a version 4 right now, and I think I kind of got lucky in that sense.
Okay.
That there was nothing, like someone at a conference last month in Japan, they asked me, is like, do you have any regrets about like the format design right now? And I'm like, I thought about it. And I'm like, not really. It's not
Okay.
perfect. Like the design overall has very specific trade-offs, like it's almost stupidly simple in some sense. And
Yeah.
I didn't want it to like get too carried away. I didn't want to like embed CRS information and that kind of thing. I would say the lowest hanging fruit for PMTiles is better compression methods, but that's blocked on
Yeah.
browser implementations. So browsers only support gzip for decompression stream APIs. If that supported
Yeah.
something like Z standard, that would be great. But that is blocked on Apple, Microsoft, Google implementing Z standard support. What changes would I like to see in the formats itself? The format itself is right now it's good enough for static data. I would really like to see another format emerge that is for dynamic data, that is still like S3 optimized, that
Yeah.
handles like rapidly changing data. Because right now, like if you edited some geodata and like created a PMTiles, you'd have to replace the whole file on object storage, and
Yeah.
that is a huge trade-off.
Yes.
Thankfully, a lot of the data out there is like you can generate this like building data set once, and maybe once a month maybe once a month you run a new job and it generates a new one. Each time
Yeah.
you are replacing it. What I really want to see is a cloud native storage engine for like real time data. That would be a totally different design than PMTiles, but I think it's still possible to do like a cloud native thing on S3, for example, where maybe you have data in chunks and then those chunks are sort of addressed by like a hash. And then you have a header that is just a reference to hashes. And then like as you upload new data or the data changes, you create new chunks and reference those, and then garbage collect them. So I would like to see some other new format separate from PM tiles that addresses real time data. In terms of new
Yeah.
tools for the format, sort of along this line, one experimental tool I have for PM tiles is a way to do deltas. So you have to
Okay.
replace a PM tiles on S3 each time. But I
Right.
was thinking about like a way to rsync data. Like if you have like a 200 gigabyte PM tiles on the cloud, and then you
Yeah.
have 200 on your desktop, and they're mostly the same, but one part has changed, you can use an algorithm like rsync basically to just fetch the parts that have changed. So that's
Right.
like one way from like the cloud to your computer, not the other way around.
Yeah.
But I would like to see some use cases for that because I sort of built it as an idea, but there's not really a strong, compelling use case right now.
Yeah.
So that's those are a lot of my ideas for the PM Tiles ecosystem right now.
Okay. I love that. Um, you're you're unearthing some feelings about source and like so we want source to be kind of this like one-to-one proxy between like for S3, but the idea being that we can create durable URLs that are undergirded by as many object stores as we want. So like if you have an object, you should be able to mirror it in lots of different regions and across clouds. And if you have your own S3 compatible object store, like we should be able to point to it and stuff like that. But a really interesting thing happened. If you go to, you'll have to look around on this, but like the data.source.coop repo on GitHub, which is the repo for our data proxy. This guy Sylvain Lesage, who we've been working with on viewers, you've encountered him on GitHub.
Mm-hmm.
He's like, oh, it's weird. Like Hugging Face can stream CSVs, but S3 can't. And he looked into it, and it had something to do with some header stuff that I don't remember the details of. But it was like an easy add to the proxy that was basically just like it would pass some more information in the header if you're when you're calling the CSV, and you can stream the CSV. And so like we've crossed that line. It's like it's sort of like, oh, we're going to do something the S3 API doesn't do, and I can see us going down a path where we are more than just like a very simple abstraction on top of S3, but we're extending what object stores can do. So we should keep talking about that.
Right. And also like so going back to the idea of like a top down versus a bottom up standard. So S3 has
Yeah,
become like a de facto standard, like a totally
that's right.
undocumented standard where
Yep.
every other vendor like sort of only implements the features they need to be S3 compatible. And if
Yep.
something is like wrong or like broken, they're like, well, that's how S3 works, you know?
Right.
So it's sort of
Right.
become this odd thing where this quirky design that Amazon came up with is
Yeah.
now like what everyone has to do de facto because all the tooling is built with those assumptions that
Yeah.
like this API, this XML API exists. They're trying to do new things though with like there's that like S3 Express One Zone that works differently.
Yeah.
There is I think a new way to do like partial uploads. Like you can define an upload as being copied from a different object, and that's like accelerated.
Yeah.
Um, but yeah, like it would be cool if some other company came up with like an actual like maybe a more a more featureful spec for S3. But
Yeah.
again, probably why it succeeded to the point it has is because it's so simple. It's like dumb, you know.
Well, right.
There's no fancy semantics around like content hashes and stuff. Like if you look at how Google storage works, you know, it does seem like they had some some whatever like level 7 engineers sit in a basement for months and like come up with some cooler design that is like more correct or that is more scalable.
Yeah.
So
Yeah.
there is platforms like Google Storage that seem to have more sophistication than S3, but they don't have the adoption of S3 in
Right.
terms of the API. Not the specific Amazon platform, but like the API, the interface.
Yeah.
And I think that is like a fundamental thing, which is there's always going to be this trade off between like the simpler and dumber you make it, the more likely it is to thrive, like thrive organically. In terms of people being able to write their own implementation, people writing tools. That I think is also like the trade-off between something like PMTiles, which is, like I keep saying, it's simple and dumb, versus something that is
Yeah.
more full-fledged, like a server application that serves WMS tiles, for example.
Right. Yeah. I mean, so we just have to be very careful with how we go about this. I imagine you're familiar with the concept of pace layering or pace layers. You ever heard
Pace
of this?
layers.
Yeah.
I don't
So
think so.
I'm putting another. I'm just going to be putting stuff in the chat. So it's an idea I think Stuart Brand came up with, which is basically the notion that like that society, like the world, like society is our experience as humans moving through the world. It's based on all these things that are moving at different rates. So like nature like undergirds everything, and on top of that, like we have all kinds of different life forms, and then humans have developed culture and governance and law, language itself. But like these are all layers that like they evolve at faster and faster rates. And the funny thing is like sort of the top layer of the pace layer diagram is always like fashion, which is like all over the place. But like fashion is this kind of like unpredictable crazy thing that humans do, but that's based on these other more sort of like foundational things like markets and law and language and blah blah blah. And so that's how I mean, I was at Amazon for 8 years. So like, and I totally bought into the philosophy of AWS, which is to provide primitives, provide primitive services that are reliable and are effectively, um, you know, extremely durable. We had an AWS crash quite recently, so things go wrong, but it's pretty remarkably stable service in terms of like how complex it is and how much stuff it off, how much stuff it supports. But the way they do that is by being very primitive. But I would say there's to your point, like there's obviously like room to extend that, and I think the right way to go about it or to think about it is to extend on top of the primitive, but like to go slowly. You want to add layers very carefully on top of it. All right, let's see here. I make sure that I'm figuring out this like chat stream thing. Like I can see it here in Riverside. Sorry, everybody out there, but we're still like figuring out how to do this thing. So I'm curious to get your. I mean, when did you realize you could just do a really huge file, like just like one gigantic file?
Um, so I started Protomaps, the project, before I created PMTiles. And the original plan was to have a server process
Yeah,
that like served tiles out of a database. So the original design was like not like it was not like cloud native or cloud optimized at all. It did not use range requests. It was
yeah,
like it was still one file that you like stored on a server, and you had to like run this program to be able to like serve it over HTTP.
yeah,
And then I eventually figured out that I could sort of cut out that entire part just by making it something that you could put onto like on S3 as a static file.
yeah.
So that actually came in probably like 1 or 2 years into the project.
Okay.
Um, for me, it's like, or so in a lot of cases, like that idea of being locked into using a server process to like serve the tiles,
Yeah.
that is sort of like a feature. Like for most businesses, like if you have to run it on server, that creates like lock-in, and you can
Exactly.
monetize
Yes.
that. You can add a paywall. You can say, hey, like so if you want to like be able to access this thing, it goes to the server. Just like get this API key. Once you go over like 10,000 requests, then you can pay like a subscription, like pay as you go. So that's
Yes.
like a feature, is to be able to like have it be a file like on a server versus just a single static object. Um,
Yeah.
but then like once my thinking around like, okay, well, like what is the long term way this project succeeds, I'm like, oh, isn't it more interesting to have it just be this like single object that you can copy around, like so
Yeah.
as if it was a video. So
Yeah.
right, the original like motivation for the project was coming from like being able to create custom maps and host them yourself. Just the nature of how that was hosted evolved from being a traditional, like, sort of SASE server thing to
Yeah.
being this, like, object storage focused thing later on.
Okay. Fascinating. Yeah. I mean, the this notion that if you control the server, if you have to be this intermediary, you get to control the data flows and also the users. And I was thinking like studying Netflix is a really interesting thing to do if you think about like a data business. Netflix is a data business. They sell subscriptions to data, and the way they're able to do that is by controlling the entire interface, like the entire chain. And so you have to go through them and pay their subscription and experience, have the Netflix experience, which is good. The fact is like there's a huge audience for that kind of data, which is videos that people like to watch. Um, and they've just nailed the experience and people are happy to pay for that, whereas like there are certainly people out there that are like, nope, like you have to have your own DVDs or I'm going to run my own local NAS with a bunch of my own video files because I want to have control. But most people are like, whatever, I don't want to have to think about this. And um, all I'm saying is like I'm underscoring the point that like there is a business in providing that kind of service to people, but um, the market for maps is way too small to justify that kind of thing. That's why I think so many geospatial like SaaS companies have had such a hard time because they might be able to provide a great experience to get some vectors and rasters and stuff delivered over the their interface, but like the market for it's just way too small to justify it. So anyway, I'm a fan of your approach for obvious reasons. And I'm sorry. Let me just keep going because Rachel Googler on LinkedIn asked, this is relevant to this. She asked, she said, with the AWS outage last week and Azure issues today, which I didn't know about that. We've seen how reliant we are as a society on centralized cloud infrastructure. How can cloud native formats be used in temporary local area or peer-to-peer networks when that centralized connectivity is gone, such as during natural disasters? So I think you kind of answered her question right away, but do you want to address that kind of idea directly, like how you think about this?
So I think of like the Protomaps project as something that works like on a server or works on S3, but also as something that works on like an SD card. It's
Yeah,
like if you can put a map or you can put a data set from source, like a scientific data set, onto an SD card and carry it into the forest, then that is like that's good enough, right? That's how most
yeah,
technology should work. That's how videos work. That's how Word documents work. So I think once you've built the primitives, it addresses a lot of these questions around like portability and being
yeah,
able to be resilient against like certain failures of networks, for example. Um, there is some interesting things around peer to peer. I know one of the contributors to PMTiles was like playing around with IPFS, which is like this distributed storage system, like where everything is like addressed by hash.
yeah, yeah,
I don't. I think it's cool. I don't know a lot about it, but I'm happy to hear that just designing like a simple single file format can be directly applied, or like it just works with these things like IPFS.
yeah,
Um, and I haven't seen a lot of adoption for that specific peer to peer system outside of some more niche use cases.
yeah,
But in theory, so you could build a really like a really resilient network of storage for any kind of data, as long as what you're trying to serve is just like these simple files.
yeah, yeah. Well, I mean, and again, I mean, I think the sort of the Netflix example is a good one to explain this, like to highlight also sort of Rachel's point of like these single points of failure that can occur where like if you are relying on one system to be able to deliver content like in a very specific way, if that system is brittle, goes down for any reason, like you're hosed. But this is core to the like the file based approach to data architectures, or what I would say specifically the object based approach, because I like object storage. But like, is that resilience in the face of like a system going down? To your point, like you can put on an SD card and take it into forest. Like that's perfect. That's a great way to think about it. There's kind of no way of getting around the power and effectiveness of SneakerNet. However, this opens up the door to a question that I've had about PMTiles, is that you've created PMTiles as this format. If I show up with a PMTiles file on an SD card and give it to a random person, they will not be able to open it. They're going to double click on it and be like, "What is this?" How do you get away with that?
Yeah.
Yeah.
I think it's tough because like it sort of depends on the observer, right? Or the person opening it. Are they opening it on Android? Are they opening it on Windows? Can I go talk to Apple and ask them to put a PMTiles viewer into Mac OS or something? And I think like my solution is this web viewer. There's a website called pmtiles.io that I maintain, where you can just like drag and drop a local PMTiles file or a URL of a PMTiles like on the cloud. So the sort of intention was like that viewer like emerged at the very beginning. I'm like, there has to be like essentially like a file preview for these things that works locally too. Like you shouldn't have to like spin up a web server to be able to look at something, because like, so the thing about data is like people want to look at it. People don't believe that it like exists until they like can see it.
Right.
It's just like this like inherent bias, like, so we know the machine can read it. People don't trust it until they can look at it. And that is a lot of why people care about PMTiles overall, is because they might have geodata in some format, but if they want to visualize it, they have to turn it into some like more visualizable format. And that's really what PMTiles is making visualization easy. So the answer for like the web viewer is, as long as they have a copy of that web viewer, which is open source, on the USB stick, then they should be able to open that offline in a browser and just like open up that PMTiles file. That viewer is built using all like pretty standard web stuff. It uses MapLibre and some like browser APIs.
Right.
But
is that all built? Can that viewer be? Could that all be? This is a very naive question. Could you just have like an HTML file on that stick that contains the entire viewer?
And a JavaScript bundle, there is a static build of it because it's hosted on GitHub Pages actually, and GitHub Pages is just static files. Yeah. So you could just like clone down a copy of that HTML, JavaScript, CSS bundle and have it offline. Yeah, and that should work. Yeah. There is this like interesting question though of like, okay, like there's certain like formats like for archiving that are like, I think it's like the Library of Congress. They have like standards about like, they recommend JPEG as a format because it's like based on the likelihood of like in like 50 years, there's like some like library science people that are like, oh, like we have these like historical like scans of like restaurant menus, but how do we open them? Because there's this image format that like was popular, back in the 2000s, and now nobody can read it. So there's like this open question of like, is PMTiles like a resilient format but like by that standard of measure? And I think that the way the format is designed, it could fit on one page. It's like I know people that have written like a implementation in a different language, like Rust or Swift or something, and they can do it in like a day because the format is intentionally like as simple as possible. Like going back to that QOI format, it's just like it needs to fit on like one PDF page. It can't be like a white paper, like 200-page book to be able to write a reader. So like my hope is that even if all of, if GitHub, like gets blasted into the sun and we lose all the code, but you have to like write a reader for PMTiles like from scratch, and all you have is the spec. I don't think it's that hard. It
Yeah.
should be doable. So even if you didn't have like that web viewer or a thing on a USB stick, you could figure it out.
Yeah.
Yeah.
Amazing. This is great. We'll be announcing this right away. But the next episode of Great Data Products is with uh, we're pretty sure it's going to be with the Harvard Library Innovation Lab. It's the Harvard Law School Library Innovation Lab. So where I've found like my kind of librarians, that are thinking a lot about, understand the benefits of object storage and these, primitive commoditized layers of storage, but they have a lot of thoughts about this. And um, we're talking about many different types of content, but I want to make sure they hear this, because your thoughtfulness on this, I think, is like really, really great. I mean, thinking, the tagline of this podcast is the ergonomics and craft of data. And you're thinking so far ahead, like, what are the ergonomics of like finding a PM tiles file in the like rubble left after the nuclear like winter, and people being like, oh, actually I can figure this out. So, um, what, yeah, the great experience you're thinking of for the future archaeologists.
Right. So just as a
That,
comparison point, like
yeah,
it's probably fine to like sort of bash on Esri stuff here. Like, so I don't think I'm like,
sure,
or so I'm not bashing on it, but even like file geodata, like a file geo database, which is like an
yeah,
FGDB format. There are city governments that publish FGDBs and they expect you to open them. And like most developers that are not in the Esri ecosystem cannot open these files. Like I
yeah,
think like it might have been like in New York City, like they distribute their like road network as an FGDB, and that format was maybe designed like 15 years ago, and even
yeah,
then, most people I talk to are like, "What do I do with this file? I have no idea what to do with it."
right,
So that's like an extreme example of like, well, it's not even a question of like 50 years of uh, uh, like of being able to open the file like in 50 years. It's a question of like even 5 years later after you publish it, can anyone deal with this thing? And it's
yeah,
like, well, not really. I think it's like kind of proprietary, or maybe there is some spec.
right,
But even things like shapefile, like was proprietary from the very beginning, right? And then people sort
right,
of like kind of made some like reverse engineered like readers for shapefile. And even then, there's like undocumented extensions for like doing indexing and stuff on top of shapefile.
yeah,
But it's like all those things are, I think they sort of like fail this question of like that library test. Like, are people going to adopt this if they are thinking about things like if they're trying to preserve things like for the future?
yeah. Absolutely. I mean, you're thinking the right way, uh, and what's interesting is that like Jackson says geo package. That's, yeah. There's an
Geopackage,
answer
yeah.
there. Yeah. I mean, what's remarkable about the, I mean, just thinking about this, like just how short the history of the internet and computing really is, and so it's fun to think about what things will be like 100 years from now or whatever. But like we went through a blip, I would say, where people were like, oh yeah, the way to control the market is by controlling the standards. um, you know Microsoft did that very effectively, developed incredible network effects through the doc and XLS formats that have since been effectively opened. But who cares? By this time, the damage is already done. Like that everybody uses Word and Excel, which I should also say, like, I'm not mad about. I think they're great, obviously powerful tools that everyone uses, and it's technology that's well distributed. So I'm not mad about that. But like in the future, we have to think more about exactly what you're saying, which is just sort of like, how durable is this going to be, really? And that means being very thoughtful about how you design the spec. And it's usually going to be something simple. Um, the only other thing I'll say here is that like I don't want to seem like I'm picking on PM tiles, because like if I double click on a PM tiles file, nothing will happen. The same is true for Parquet, right? And so Parquet is like all the rage. So much data on Hugging Face right now is in Parquet. We love having tons of Parquet data on Source. And I was showing a guy earlier today who's not really familiar with it, but I opened up on Source, and these are my favorite demos. And my PM Tiles demo is the best demo of Source, because we've got a great viewer built in, and you can just look at it, and it's easy for people. Um, Thank you for that viewer, the viewer that you created. And then Sylvain also built this Parquet viewer, and it's like, oh, great. Like now, I mean, as of today, somebody can drag and drop a Parquet file into Source, and they can look at it in the browser right away. And I showed this guy, I'm like, yeah, here's a Parquet file. It's 800,000 rows, and it's just like streaming right through really easily. And we're already at a point where there's so much data out there, and so many files are being adopted that like no one's even bothering developing a desktop viewer for them. It's all being done in the browser. Like it's all the expectations this can be done over the internet, which is amazing. Oh, we got some comments coming through. Yusuf from Egypt. Hello. I don't know who knows what time it is over there. He says new versions of GDAL can open FGDB now.
GDAL I think I saw that. Yeah. I think like my standard workflow now is like I downloaded like the FGDB of like it's like New York City road center lines, and then I do like an OGR to OGR and just get it into like a GeoJSON or something.
Yeah.
But yeah, I believe there is a solution now. I remember, I think there was one time like a decade ago where I like downloaded like the ArcGIS Pro trial and like activated the trial just to be able to like open the FGDB and then like save it out as something else.
Yeah.
But I think that like the status quo is better now. Yeah, for sure.
Yeah. I mean, GDAL, it's just incredible. Shout out to Evan. A few more comments on YouTube. Jackson. Hello, Jackson. He says he's in the midst of writing an implementation of GeoPackage in Julia. Good luck. Let us know.
Nice.
If you want to write about that on the CNG blog, we have a process for submitting stuff to the blogs. That'd be cool. It's 2:52 in the morning where Yusuf is. So, Brandon, you are very popular. People are like, this is incredible. You get like sun never sets on the Brandon Liu Protomaps empire. Like, and then we've got Sigtil again from Norway. Staying awake. I love this late night energy we're getting. Asking, how do you see the new kid in town GeoParquet versus PMTiles? They have some of the same properties and some differences also. As you said, there's a lot of nucleative. Yeah. So yeah, I mean, we have Zara, Cog, flat geobuffs. How you've explained this to me before, sort of the nuance between like what PMTiles does as opposed to what GeoParquet does. I mean, I have my own guesses about this because GeoParquet is like more about like data than PMTiles, which is more about viewing. Is that how you would describe it, or what's your response there?
That's how I see it. Yeah, like so, I make the distinction between like like a format for that is for analysis, versus a format that's like for visualization. And I think that's like maybe not intuitive because in some cases those are the same. Like for Cog, viewing it and analyzing it are sort of the same because analyzing it means like what is the value at this pixel, and viewing it is like show me the raster, colored in some way. For PMTiles, a lot of the use cases right now for PMTiles are vector based, and for vector, you sort of need to split out the analysis and visualization into separate things, because if you wanted an overview for a vector data set, you can't really show everything. It would be too noisy. So PMTiles is inherently generalized. Like it has like an overview pyramid. So you can load it at any scale and it looks correct. But what you actually see at that level is like not everything. You have to do some filtering down of the data. Sort of like for cogs, you have to build overviews that are like smaller and smaller downsampled resolution, like images of the full thing. So GeoParquet does not have a lot of use case overlap with PMTiles because GeoParquet is like an analytical format that is all it's just like all the raw data and then only one version of each data point, while PMTiles will have copies of a single data point because it has to build those overviews. Now there are like approaches to using GeoParquet and visualizing it directly. Like for example, so there's a project called Lawnboard that lets you just show GeoParquet on a map. Whether or not that's practical to use like on the web really depends, because if you want to be able to download like an entire geoparking data set to visualize of a city,
Yeah.
that might be like 200 megabytes, which is more
Yeah.
than people usually expect for like a single web page. Um,
Right.
I mean, it's possible that in 10 years, like bandwidth will be so fast and cheap that downloading 200 megs for a single web page might not matter. And maybe we like at that point, we don't actually need like a visualization format. We can just be downloading raw data like everywhere. But I
Yeah.
expect like some sort of strategy around being able to visualize data with overviews is always going to be necessary, just because like some data sets are just really big. Like there's building data sets on source that are like maybe half a terabyte, like the like open buildings data sets.
Yeah, the Vita data sets, those are my favorite demos. They're like 300 gigs or 230 gigs or something like that. But like, yeah, it's
Yeah.
like it's only going to be streamed. My assumption is that storage will keep getting cheaper. We'll be we'll getting we'll there's still plenty of room to progress in terms of like the cost of storage itself, but bandwidth networking has like actual physical limits in terms of like the speed of light that I think are really compressing space like that. Like the movement of bytes over space or across space is really hard. So um one okay. Oh, actually, Qiusheng Wu, awesome to have Qiusheng on here, says that DuckDB supports serving vector tiles through Parquet. Said that on LinkedIn.
Nice.
So cool. It's great. And then we have another. I want to talk to you about the Hilbert curve. We're getting at about an hour, so we can maybe start wrapping it up. But then Alex Kovac asks, and I'm going to test this out. I'm still figuring out how to do this.
I see it.
Yeah, you can see it. Okay, so how did I think the people on LinkedIn can't see this? So this is tooling on PMTiles, and also for the purposes of the people listening after the fact. Alex says tooling around PMTiles, such as the viewer, CLI, Tippecanoe, base maps, package, etc., is super convenient. Um, how did that evolve, and do you think there's anything big missing? Uh, yeah,
Yes. The like I think part I put the most thought into was the overall like developer experience of using PM tiles. And like from the
yeah,
beginning, it had to be like a single binary you could just download. Like I did not want you to have to
yeah,
like homebrew install or like npm install or like Python package install a package, just because that's going to fail for a lot of people. If
yeah,
you've ever been to a workshop where people like use Python, like a scientific workshop where people are like, "Oh, we're providing the material as like a Jupyter notebook," and then someone's
yeah,
like, "I'm on Windows," and then you're like, "Oh, just use Conda," and then you're like trying to like fiddle with this Conda setup, and I'm like,
right,
I just don't like I feel like it pushes people away. Like I understand that like that tooling
yeah,
is mature, but for me, it's like I think the best developer experience for any sort of data tooling is like just download a single binary. Like those are
yeah,
the tools I see having the most adoption and least problems in terms of like the installation. So the installation has to be super simple, like a single download. The viewer we talked about is like the web viewer is for like the viewer for PM tiles files to just browse them.
yeah,
I would say um, if there's something big missing, I think Tippecanoe is great, and PM tile support for that is built in thanks to Felt. Um, but I would say it's still too hard to install. Like a lot of people
yeah,
that want to build PM tiles, they get stuck on like how do you install the vector tile generator. I would
right,
say that is the biggest missing piece, which is to have a like single binary download vector tile engine.
okay,
Uh, like a lot of the limitation for that is because the libraries you need to do geometry, like geometry processing, are generally only in a couple languages like C++, Java. Um, and right
yeah,
now, the CLI is like a Go program, and there's no good libraries for that in Go. Even Rust doesn't have that great of support. You probably need to bring in GEOS via C++ bindings.
yeah,
Um, so the biggest missing part is still like some easy to install and like large amount of data generator for vector tiles. It's
Yeah.
something I do want to work on, but right now I think the Tippecanoe solution is like good enough.
Yeah.
But it's the major pain point for using PM tiles.
Yeah. I mean, talk about ergonomics of data. Like you're just the way you think about this is so great. Everyone learned from Brandon. You're so thoughtful. And it's I mean like this is also just kind of like see this like is you're helping level up the species, just by thinking through things this way. Because yeah, it's so goofy. Like I mean, I've been in all these like hackathons in these rooms where people are like, oh yeah, like you end up spending half the time debugging people's Python installations, and it's just like, no, there's got to be a better way. Um,
Right.
yeah,
There's also this idea of like of different kinds of complexity. There's like inherent complexity versus incidental complexity. And I think a lot of like solving these pain points is around solving incidental complexity, which is just complexity that happens to be there as like an artifact that is
yeah,
not related to the actual problem you're solving. Like maybe you're trying to solve some route optimization problem, and that is it's like is inherently a interesting computer science problem. But
yeah,
then the incidental part is like, oh, I need to like install these packages with Conda, and Conda's the like
right,
doesn't like it's the wrong version on my machine or something, and it's just like all that stuff is just like the part that is like we can really like we have to eliminate that in order to actually get to working on the hard problems.
yeah, exactly. There's what's the line? It's sort of you make the hard stuff easy and the like impossible stuff possible or something. There's some axiom around like guiding software development along these lines, which is like we should be continually progressing in that direction. And but you're asking all these great questions or like framing it in the right way, which is just sort of like you imagine somebody who's coming to a hackathon, how quickly can you get them up and running? If you're going to take an SD card into the forest, like what can you actually do with that, like realistically? Um, and I often think in terms of like, well, this is what I was saying before about like Excel and Word having, being very successful is that they are sufficiently distributed technologies. The whole idea that like the future's already here, it's just not evenly distributed. There are some that are like evenly distributed, like spreadsheet software. Like everyone can open a CSV. Like that's awesome. CSVs are great, like because of that. Um, but as we're getting better at producing more complex forms of data, we need to think about the ergonomics in that way. Like, what are the experiences of people who are being introduced to this? So, um, Yusuf says that Tippecanoe in Windows is a nightmare. By the way, so
I've heard
FYI.
that as well. Yeah,
um,
yeah, I'm aware.
so I remember years ago I asked you if you'd ever seen the movie Tar.
Which I still haven't, but I need to now
Okay.
that you've mentioned it
Well,
twice.
I just like Tar is a weird. Tar fans come out and tell me if you've watched the movie Tar. It's Tar with an accent on the A. It's a Todd Field movie, um, in which David Hilbert is a character of sorts. Like he just shows up in the background, and I think there are references in the movie to the Hilbert curve. Um, Tell me about the Hilbert curve. Oh, let's close on this. Why the Hilbert curve, and how did you get into space filling curves? I love this stuff.
Uh like I kind of ripped it off of S2. So S2 is
Okay.
Google's
Yeah.
geospatial like indexing library, and they use the Hilbert curve there. It has
Yeah.
some nice properties that make it work well for geodata. Um,
Okay.
and um, the motivation behind this is even in like in cloud optimized geotiff, people argue about like, oh, like so we're making like a cloud optimized format, but like how big should the blocks be? You're like fetching
Yeah.
blocks. If you have small if you have small blocks, those are good for certain use cases.
Yeah.
If you have big blocks, those are good for more like bulk downloading use cases. It's more efficient. And there's some trade-off between small blocks and large blocks.
Yeah.
Um, but the Hilbert curve is like a way to like is like a lazy way to get around that argument, which is because like it's both small blocks and big blocks in the same format. You can actually have any size block as long as the power of two.
Yeah.
And the reason this is good for PMTiles is because one of the operations on PMTiles is for extracting one part of the world from a larger file.
Right.
And the imagined use case for this is so I host my OpenStreetMap dataset on the cloud, but maybe you only care about Seattle. You know, like you don't want to have
Yeah.
a copy of 100 gigs of the whole world. You only want Seattle.
Yeah.
Or like maybe you only want Capitol Hill. So the block size in the archive should be small if you only care about a neighborhood. But if somebody else wants all of Canada instead, then they want to be able to have a format that has big blocks so they can download Canada in one chunk.
Right.
So the Hilbert curve is useful because it encompasses both of those use cases without having to make a trade-off. Because if you did small blocks, it would be good for Capitol Hill, it'd be bad for Canada. If you did big
Yeah.
blocks, it'd be good for Canada, it'd be bad for Capitol Hill. So because the Hilbert curve is sort of scale free, it has the same self-similar structure at every power of two. You sort of get the
Yeah.
best of both worlds in one thing. And that's really the motivation for why the Hilbert curve was useful for this design. I would say it's not fundamentally essential. You could build a pretty good format just using like other space filling curves or like a Z order curve.
Okay.
There is some drawbacks in terms of it's more computationally expensive to decode the Hilbert curve versus other ones.
Oh, interesting.
For example, the Bing there's these like Bing quad key tile indexes that are much faster to compute than the Hilbert curve.
Okay.
For most use cases, though, the cost of decoding and encoding the Hilbert curve is trivial compared to like the network. You know, if
Yeah.
it spends like 2 milliseconds like doing a bunch of tile coordinates on Hilbert, then you're spending 50 milliseconds like fetching something over the network. So like overall, like holistically, the price you pay for using the Hilbert curve is not that much relative to other things going on
Yeah.
in some actual use case.
Yeah.
But that's like kind of the whole story as to why we use this like weird thing that is apparently in a movie as well.
Yeah. I mean, just the
Yeah.
movie. I turned the light red again just because it's a kind of a spooky movie. Um, there's BV on YouTube asked a question if H3 grids are similarly useful, but one thing I want to clarify about the Hilbert curve and like to make sure I understand it, which I'm pretty sure I don't, which is that like the idea is that you can map two dimensions along one dimension, right? Like with you just have like one string that can be extended into two dimensions, like effectively anywhere at any resolution you want. If
Right.
I'm loading up the Canada tile, am I just loading up one band? Like how does it work? Like, or is it making multiple requests to do that? Can you explain that even? Like, it sounds like the kind of thing you would need a whiteboard to describe, but
Yeah, it's you're opening up multiple like so if the entire world is on one like length of string,
yeah,
then Canada is multiple segments of that range of string.
yeah,
Now, where you can adjust is like how finely tight like how finely traced the borders of Canada are,
yeah,
because if you're working in like a networked environment, you can do
yeah,
some optimizations. You can say, oh, like I'm going to grab a little bit more data than I need,
yeah,
but have less ranges. Like I can
right,
represent Canada using fewer segments of string, even though I get a little bit of America, like on the side.
right,
Um, so it is pretty much that. Like there isn't really one Canada tile, but you can sort of trace out a contiguous segment of the file that is all next to each other, that is all inside of Canada, and then maybe grab a little bit on the sides for like different outlying areas. But the interior of Canada, as long as it's like an area, like most countries in the world or most regions are not like Chile, where it's just like one long thing. Most of them
Yeah.
are like kind of rectangular-ish. They have like an interior and then like a border. Um, so this sort of space filling curve is well suited to how people usually think about areas as having like an internal volume and then being able to slice that into just parts of this space filling curve without having
Okay.
to like use an excessive amount.
Got it. And then one follow up question on that from the chat is that is there a benefit here that also these requests are close to each other? I I would meaning like if you want to look at the full Canada tile and then like the Vancouver tile, should they be near each other? My intuition though is that that shouldn't matter with object storage and range requests because it's not like you're he's saying like it's similar to like how you would defragment an old spinning hard drive, but like that's not how object storage works. I mean, we're not assuming that we're using spinning disk. We might be, but
Right.
do you
So
have
it matters
any
a lot on
insight there?
HDDs because it's like on
Yeah,
those old spinning hard drives, it's like you have to
you
move
have
the
a
needle
head.
more if they're
That's right.
not by each other.
That's
But I
right.
think most storage now is solid state, and there's not a huge difference in the seek time for like a far away chunk versus a near chunk. Um,
Yeah,
but yeah, there is also benefits to certain operations. Just having parts that are close in space also be close in the file.
yeah.
That is taken advantage of in some parts of the tooling.
Okay. And then let's. Do you have opinions about H3? I mean, so BV is asking, are H3 grids similarly useful? I see it as probably not, but I don't know how H3 content is. H3 is more of like an indexing concept.
H3
You
is
know?
really useful. It is really useful for visualization. Um,
Yeah.
let, yeah, I think it's like so H3 is like you're usually storing like a value in each cell, and I
Right.
think it's really great for making like really good looking visualizations of data
Yeah.
um, with hexagons. There is some trade offs, like in H3, one hexagon does not perfectly nest its child hexagons, while in tiles there is a perfect nesting.
Right. Right.
But for certain use cases, like showing like aggregate statistics, it doesn't matter. So I would say H3
Right.
grids are the perfect use or are the perfect match for certain use cases around visualization that are
Right.
separate from doing tiling.
Yeah. Exactly. Yeah. That's
Yeah.
sort of my understanding, and it is especially good for like visualization, but then also like statistics. Like, so if you're doing like analysis on, I mean, you just think about the origins of it with Uber. Wanting to measure demand and activity in very certain areas at different grains. It's like perfect for that. So
Mhm.
um okay. Well, look, we've been going for an hour and 15 minutes. This is incredible. We've got people staying up to all sorts of crazy guys go to bed. Again, there's a podcast. Like this audio will go out so you can listen to it whenever. Um but I really we have been honored. People are honoring us with their time. I hope this has been interesting for them. Brandon, I love talking to you. I obviously love what you're doing. We're very proud to have you as a Radiant Earth fellow and have had you as a fellow for a long time. Um oh man, are you serious? This Sigtil in Norway won't let up. He's got to go to bed, but he's asking more questions. Are there some geometries that are not supported or more difficult? For instance, polygons with oh boy, with holes and holes made of curves, etc. What was the most difficult geometry to work with across tiles? This is this is too hard of a question.
No, it's
Are you
like
seeing
I'm
this
able to
comment?
address this.
Go for
Yeah,
it. All right, do it, and then we'll
I mean,
wrap it
this is a
up.
good like deep question, but it goes back to what I was saying
Okay.
is that there is certain geometries that are hard to deal with. Um,
Yeah.
and a lot of it is you have to have a geometry library that is very robust against certain like numerical precision errors. And the only libraries right now that get it totally right are basically like
Yeah.
GEOS, which is part of PostGIS, and
Yeah.
JTS, which is a Java library that is related to GEOS, and then a couple other
Yeah.
ones. Like there's one that Mapbox made. Um,
Yeah.
but yeah, like that difficult geometry is the limitation in being able to write like an easy to install vector tile generator.
Yeah.
So I would, I'm happy to follow up over email or something if you want to like know more about like geometry processing, because it's like a really deep subject that like sort
Yeah.
of is is a stealth hard problem. People don't realize how hard that problem is until they like find some weird geometry that's broken.
Yeah.
But yeah, that is a good question. And
Great.
again, I'm happy to talk about it more.
Okay. And then, so to contact you, um, I'm going to just put in the chat protomaps.com. Go to protomaps.com. There's info down at the bottom with how to reach you. Uh,
Uh-huh.
so you're easy to reach. Obviously, everyone listening to this knows how thoughtful you are. So anyway, I mean, thanks so much for what you've given to our community. Um, can't thank you enough. Anything else you want to? Anything else you want to talk about? Anything we missed?
Um, I just wanted to say thanks for having me on the podcast. I am also on the CNG Slack, the Source
That's
Cooperative
right.
Slack.
Yeah.
Which one do you want people to use? If people are CNG
Um,
members,
well, so yeah, so
then they can
CNG
join.
members, you got to be a member to. It's for both. You kind of have to be a member. So membership to CNG is pretty cheap. It's we say it's a symbolic fee. So it's these memberships don't really add up to pay many bills, but we ask people to pay to join CNG just to make sure that we know that people are there on purpose. They really want to be there. So join CNG if you're not, and Brandon's in the Slack there. Source is still like invite only, but Source. So yeah, best point of entry right now is the CNG, the Cloud Native Geo Slack. You can go to cloudnativegeo.org/join and learn how to learn about it there. I'll put that in the chat as well. Um, but yeah, would be great to see people interacting with Brandon on in our any of our Slacks. But he's easy to find otherwise. All right, and then it's what is it? 8:17 in the morning there now.
It is, yeah. It's
You got a whole
Brandon
day
Liu.
ahead of you. All right. Well, happy Thursday. Um, thanks again for doing this. I bet we'll do it again.
Awesome. Yeah,
All
I'm
right.
looking forward to the next episodes.